Well, welcome, Mr. Kolazar's class. Today we're going to look at drawing the Lewis dot structures to represent our molecules. And so this is part 2 of our advanced bonding structures. So to begin with, what we're going to do is a little review. Remember, the group number on our periodic table is going to equal the number of valence electrons for group 1 and 2, and then skipping the middle block, the transition elements, and moving over to our rest of our main group, groups 13 through 18, minusing 10. So we continue the pattern of 1, 2, 3 outer, 4 outer, 5 outer, 6 outer, 7 outer, 8 outer electrons. So make sure you have your PT, periodic table, with you so you can quickly look back to see how many outer electrons or valence electrons each element has today. So an example Lewis structure, if we were just to take period 2, lithium would have 1 outer electron. Beryllium would have 2 outer electrons. Sometimes they're shown side to side. We've been showing them on top. Boron would have 3 outer electrons. Carbon is unique in the fact that it's going to spread all 4 carbon of its electrons out. And then continuing, nitrogen, 5 outer electrons. Oxygen, 6 outer. And finally, I've got fluorine with 7 outer. And then our noble gas, neon, does not want to gain, lose, or share. It's got its full octet with 8 outer electrons. Get those dots a little bit bigger on that side. So now we've looked back over our number of outer electrons for each group. What we're going to do is introduce a little bit of terminology. Now these are just listed left to right in your notes, or top and down in mine. So we're going to draw out this structure here. We'll put some pairs of electrons in. And this structure I'd like you to draw in because we're going to go through and point some things out. Our first one we're going to look at is going to be our bonding pair or shared pair of electrons. So that's going to be right here. This is one single covalent bond. So please include that in your notes. Now, for a single covalent bond sharing, for a covalent bond, to share, if oxygen is going to share an electron with nitrogen, nitrogen must share an electron back. That means we have 2 electrons in that one dash that's occurring there. Now, on the other side, we have what is going to be known as a double bond. And a double bond instead is going to be 4 electrons shared. So we have our single and our double bond. There's even a triple bond out there we'll see later on. That's as much as we can get. So single bond, double bond. Then we have our lone pair or unshared electrons. Those are going to be any of our pairs on the atoms that are not being shared. So those will be our lone or unshared pairs of electrons. And our final one is going to be the lone electrons. Lone electrons, I put at the top here. These are sometimes known as free radicals. You might have heard that term in health or in other places. Free radicals, we're going to try to avoid having any single electrons. They're highly reactive and unstable. They want to go after almost any other element to grab an electron from them, and kind of can cause some chain reactions. So we try to avoid having any of those. But those are going to be our terms that we need for making our Lewis structures. So to begin with, we have 4 steps. I guess it's 3 steps and to check over one. So first off, 1, we're going to determine the number of valence electrons. So the group number will indicate the number of valence electrons. Step 2, if there's a positive charge because we have an ion, positive charge would be less electrons by how much? Or if it's a negative ion, more electrons by how much? So our first step is we're going to find out how many valence electrons we have in carbon tetrachloride. We have 1 carbon from our formula, and carbon has 4 valence electrons. So 1 times 4, 4 valence electrons from carbon. Chlorine, we have 4 chlorines, and each chlorine's group 17 has 7 valence electrons, giving us 28 total electrons. So 32 electrons are what we're going to need to show in our Lewis structure for carbon tetrachloride. Keeping that in mind, our second step says we're going to draw a skeleton by joining the atoms using single bonds, or a bonding pair of electrons. If the molecule only has 2 atoms, they're placed side by side. If carbon is present, it's the central atom. If there's more than 1 carbon, we're going to make a chain of carbon, so it kind of looks like carbon, carbon, carbon. If carbon is absent, the element with the smallest amount of atoms is placed to the central atom. Then we're going to replace all remaining atoms around the central atom, top, left, right. These are our terminal atoms, and they're going to be connected to begin with those single bonds, as we saw right up at the top of the page, the single bonds. So carbon is present. It's going to be our central atom. You're going to place it there. And it says to place all remaining atoms around, connected with a single bond, at the top, left, right, bottom, placements. You can start in any place. So now we've completed our second step. Right now we started out with 32 electrons we needed to show. Now each covalent bond that we have is 2 electrons. So we're showing 1, 2, 3, 4 covalent bonds there. So in the end we have shown 8 of our 32 electrons. We still have 24 electrons left to place. So rule 3 says place remaining electrons as lone pairs around the terminal atom. If they then to the central atom if needed. Do not exceed the amount of electrons in step 1. Hydrogen's okay with just 2 electrons, so once it's bonded, hydrogen's done. If the octet is not satisfied for an atom, then change a lone or unshared pair of electrons to a paired share or a shared pair. This creates a multi-bond. We're going to call them double or even triple bonds. And we'll see that in another example coming up. If we have a polyatomic ion, we're going to place brackets around it with a charge in the upper right hand corner. In this case we don't have one. So right now we had carbon with its 4 covalent bonds. And now we still had 32 electrons and we lost 8 electrons. So we're showing 24 electrons. They're going to be dealt out in pairs. So we're going to go remaining electrons, terminal atoms, placed in pairs. So lone pairs. So we're going to just deal them like cards. A pair to the first, a pair to the second, a pair to the third, a pair to the fourth. So I've shown 8 electrons. So we're down to 16 total electrons left. So we're going to give another pair out. Pair to each atom. That's another 2, 4, 6, 8. So now we're down to 8 electrons. So we're going to pair one more time. And eventually now we have lost all of our electrons. So in this case now we are done with our third step. Our fourth step is going to be just to check your final structure so that all of the elements have achieved a full octet. Octet, remember, 8 outer electrons. Remember, hydrogen is okay with 2 outer electrons. The amount of electrons needs to equal step 1. So we're just going to go back and double check what I've shown so far. So we want to look at each element. You don't need to do this part circle-wise, but I'm just showing that this chlorine has 8 electrons, 2, 4, 6, and that shared pair spends time around both atoms. One spends time around the chlorine, has 8 electrons there. Our second chlorine, 8 electrons around it, 8 electrons, and 8 electrons. So chlorine is happy with its 8 outer electrons. Now to check on carbon. Carbon shared its electron with chlorine, chlorine sharing back, so that covalent bond sharing with carbon, each one, 2, 4, 6, 8, each carbon, or the carbon has the 4, 6, 8 total electrons surrounding it. That's being shared with chlorine, shared back with carbon. So carbon's also happy with 8 electrons around it. So we've checked off, used all of our electrons. Everybody has octet. So carbon tetrachloride would look like that. Let's try a couple of practice problems out on the backside. We're going to skip to the second one. Oxygen is O2. So oxygen, our element. We have 2 oxygens, and each oxygen has 6 electrons. So 2 times 6, we have 12 electrons to show. Our rule says that if the elements, there's only 2 of them, they're placed side by side. We've got 1 covalent bond in the middle, so 2 electrons we're going to subtract. Right now we're at 10 electrons total left to show. So we're going to start dealing in pairs. 2, 4. So we've shown 4 electrons, so we have 6 left to show. We'll go 6, 8, or 2, 4, so we got 4, so we've got 2 left to show, and we'll put them on this side. Remember, they got to be dealt in pairs. We can't go single, single. Now at this point, the first oxygen has 2, 4, 6, 8 electrons around it, but the second electron, or oxygen, has 2, 4, 6 electrons around it, so the second electron's not happy right now. What we're going to do is, it says if we're not happy with the octet, we're going to take a shared pair of electrons from the other atom and make it an unshared pair of electrons, and we're going to make that a shared pair of electrons. So in the end, I'm going to have to rewrite it. We've got oxygen, 1, 2, double bond is what we'll call that. Move those electrons over, it's alright with either placement. And in the end, 2, 4 electrons shared. So this oxygen showing 2, 4 lone electrons, and the 2 shared pairs, 4 electrons there, gives us our oxygen to have 8. And our other oxygen on the other side, 2, 4, 6, 8 electrons shared there. So it shares those with this oxygen, has 8 around it also. So in the end, when we added those 2 electrons in, checking over, we've used all total 12 of our electrons, so we are good to go there. So that would be our example or answer for oxygen O2, the air we breathe in. NO2 minus. Now notice we've got this minus sign up top. From your polyatomics chart in your gold packet, we know this would be nitrate, but that minus charge is showing us something. So first off, nitrogen, we have 1 nitrogen, times 5 outer electrons for nitrogen, gives us 5 electrons to show from nitrogen. Oxygen, there's 2 oxygens, 6 outer electrons is 12 electrons, but we have that negative, so we're going to gain 1 electron from that negative. So in the end, we are going to show 17, 18 electrons. So carbon's not present, so we can't use carbon. Nitrogen, it says the element that has the smallest amount. So we only have 1 nitrogen, 2 oxygen. Nitrogen will be our center atom. I'm going to start with our skeleton structure, bonding 1 oxygen to each nitrogen. So we started out with 18 electrons. We're going to subtract our 4 electrons, so we're down to 14 to show. So we're going to deal them in pairs. 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12. 2 left. We can't give any more to oxygen, we can't give any more, so our central atom gets that last pair of electrons. Now if we look at each oxygen, 2, 4, 6, 8 electrons around it. Oxygen, 2, 4, 6, 8 electrons around it. Nitrogen, sharing 2, 4, 6 electrons around it. So we need to take a lone pair of electrons and make it a shared pair. So I'm just going to redraw that as a double bond now. With our lone pairs of electrons still around each of our elements. Now each element has 2, 4, 6, 8 electrons around it, 8 electrons around the nitrogen, and 8 electrons around each oxygen, so each one's happy. Remember, this is a polyatomic ion, so our rule 3 says that if we have a polyatomic ion, we put it in brackets. And then that charge goes in the upper right hand corner, saying we have a negative charge, goes in the upper right hand corner. I'd like you to complete the rest of the examples on this page and then bring any questions that you have to class.